Hi, this is Dr. Bitla Venu coming in front of you with a new topic called Computer Numerical Control System or Computer Numerical Control Machining Centers. In the last sessions, we have seen the numerical control machining, which is hardwired, but now we are going to look into the machine numerical control machine, which is attached to the computer. In the previous session, we have seen that NC system motion controls. We have seen point to point, straight cut, contouring type. Then we have seen the NC system feedback control, which are having open loop as well as closed loop we have seen. Then we are also discussed the applications of NC machining. Then we moved forward to discuss the advantages and limitations of NC machining. Finally, we are discuss the computer numerical control machining some extent. But now let us see or let us discuss the computer numerical control machining centers in detail in this slideshow. The objective of this session is to discuss the CNC machines. Then we will classify the CNC machining centers. Depends on the how the CNC machining centers are classified according to the different criterias. We will see in this slideshow. Then we will discuss the basic components of CNC systems. Then we move forward to discuss the components functions of CNC system. Then we move forward to see the features of the CNC system. In this slideshow, we also try to discuss the advantages, disadvantages, applications of CNC machines. Finally, we will try to discuss the introduction of direct numerical control systems. Let me move forward to discuss the computer numerical control machining systems. In the case of computer numerical control systems, which are going to work with the discrete numerical values, so these values are fed into the machining centers using the input mediums like floppy drives, or CD drives, DVD drives, or USB flash drives. That means the programs are going to fed into the computer numerical control systems using input devices, as I said just now. When these CNC machining centers or CNC machines are going to interpret the programs which are already fed into the system using the input devices. So these are going to calculate the predetermined sequence of the machining operations. That means already we are feeding the programs into the CNC machines, so which are in turn we can call it as a predetermined sequence of machining operations. So those are going to calculate at the predetermined speed. I mean, the objective of the predetermined machining operations is to interpret the data as well as to calculate the predetermined values such as speeds, feeds, and the moments of the table. The CNC system receives and interprets the data, as I said just now, then controls the action accordingly. Let us see the manufacturing methodology of modern CNC system. As I said just now, it has a software, because computer numerical control machining system means unlike the numerical control machining centers, it is connected to the computer. Means the programs are going to be written in the computer. As and when you require, you can modify the programs because it is we are connected to the computer. So before that, you have a manuscript. Manuscript is prepared. The manuscript is nothing but a document which is going to have a program, rough program, documented on a paper. So as per the manuscript program, as per the steps listed on the manuscript, those steps are going, based on those steps, the program will be written in the computer. So this computer is going to be used as modifier whenever you want, and we have a flexibility once we have a computer in our hand. As and when you find any errors in the program, you can modify. So after completing after completing the program. So this manuscript is prepared from the part descriptions, which are in the form of 2D model or 3D model. From the 2D model or 3D model, the manuscript is prepared. So in between that, we have a process planning. So according to the process planning, manuscript will be prepared. Process planning means in which we are going to list out the operations to be performed, speed, feed, and depth of cut. I mean, the cutting parameters will be evaluated during that stage. I mean, we are going to sort out the operations, machines to be used, tools to be used during that stage, during the process planning. As per the process planning, so manuscript will be prepared, and according to the manuscript, the program will be written in the computer. The actual program will be written in the computer, and that computer is connected to the control unit, machine control unit, where the signals are transmitted, signals are converted into the machine readable form. So that those machine readable signals are connected to the machine unit or NC machine, where actual work will take place to get the desired product. This is what the skeleton or the manufacturing methodology of the modern CNC machining centers. So let me move on to the further slides. Uh, Let us see the classification of CNC machining center, how the machining centers are going to be classified. Let us see. According to the feedback signals, the first classification of the CNC machining centers are according to the type of feedback. The machining centers, CNC machining centers are classified. It may be open loop type or closed loop type. We already discussed what is open loop and what is closed loop type machines in the NC machines. Open loop means the machining centers which are not going to calculate the feedback signal, and directly it works, it executes the commands and gives us the work output. Whereas in the case of closed loop type CNC machining centers, it calculates the errors in the speed and table movements and feed. All those will be taken back as a feedback signal and adjusted according to the error. The error signal will be again sent to the machine control unit as well as to the machine unit to adjust the error. So this is what takes place in the case of closed loop type CNC machining centers. So we are already discussed what type of, I mean, these two types of feedback systems in our last sessions. Now the other classification is according to the type of tool motion control. In what way you are controlling the tool, whether it is finite positioning or continuous path control. In other terms, we can call it as a point-to-point control or else the continuous path control, straight cut and continuous path control. In finite positioning control, the tool will be moved from point to point, one point to another point, irrespective of the movement. That means we are not going to consider the movement of the tool in between the 2 points. That means it can follow any path. We're not going to bother about the speed of the tool or the path of the tool, but our focus is to reach the destination point. As and when the tool moves to the destination point, the work will be performed in the case of finite positioning control CNC machining centers. This is in turn we can call it as a point-to-point positioning. That means we're not going to bother about the a path followed by the while moving the tool from one point to another point. Now let me say something about the continuous path control. In the case of continuous path control, the it is going to be the tool is going to move from one point to another point. It may be interpolated in a straight line path, in a curved path, or in any of the irregular path. In this case, the tool is going to, I mean, straight cuts are possible, as well as the once we adopt the continuous path control, we can move the tool in a straight line path, circular path, or in any of the irregular path. This is what happens in the case of continuous path control. Now let me move on to the other type of classification. This is according to the programming methods. So you have programming, you have two different programming methods. In what way you are giving the coordinate values, in what way you are calculating the coordinate values. So you have x-axis and y-axis are the, you have one reference point in any of the coordinate system while programming or while referencing the movements of the tool. The movements of the tool or the movements of the table is according to the absolute programming. In the case of absolute programming, the tool movements are the coordinate values, or the table movements or the table coordinate values are according to the origin point. With respect to the one origin point, all the points are calculated. Whereas in the case of incremental programming, the next point coordinates are specified according to the first point or the previous point. So to specify the next point, the first point will be considered. This is what happens in the case of incremental programming. So there are two types of programming methods. So absolute programming and incremental programming. In the case of absolute programming, the coordinates are specified with respect to one point that is called origin. All the points are calculated or mentioned in the program from the origin point or one from the one reference point. You can also refer that as origin point. Whereas in the case of incremental programming, the next point will be considered. I mean, the next points is going to consider this first point or the previous point. To specify the next point, the previous point will also be considered. With respect to the first point or the previous point, the next point will be considered. Like that, absolute programming and incremental programming will work out. Then according to the type of control, so you have seen the hybrid controller and straight controller. So you can hybridize the controllers. You can mix up one or two controllers and you can use a single controller. Straight away you can control the CNC system. So these are hybrid controller and straight controller. Then according to the axis and type of operations, you can also classify CNC machining centers. According to the axis, it may be horizontal machining center or it may be a vertical machining center. These are according to the axis, working axis of the machining center. If your working axis is horizontal, you can term it as a horizontal machining center. If your working axis is vertical, you can call it as a vertical machining center. And based on the type of operation also, you can classify the CNC machining center. So according to the type of operations, if your CNC machine is specific to perform only one operation, so you are performing only turning operation, in which case you can call that as a turning center, CNC turning center. Suppose if you are doing only milling operations in that CNC machine, you can call that as a CNC milling center. So according to the axis and according to the type, you can also classify CNC machining centers. According to the axis, you can classify as horizontal or vertical, and according to the type of operations, you can classify as turning and milling centers, or drilling centers also you can classify. Now let me discuss the basic components of CNC system, or we can discuss all these in detail with this block diagram of CNC machining center, CNC machining system. So you can find the basic elements in this diagram, in this basic components of the CNC system you can find in this block diagram of CNC machining system. So in this case you can find the machine control unit, like NC machining system. In this case also you have machine control unit, or MCU, where we are going to process the data, and this will be this is also in turn, it is also having the control system. I mean, machine control unit is also going to act as a housing to process the data as well as to control the machine. By the name you can say that machine control unit, it is going to be called as a heart of the CNC machining center, from which the commands will be issued to control the machine tool. All the controlling and as well as the analyzing the data, processing the data will take place at this location, so that we can call this MCU as a heart of the CNC system. So this machine control unit is going to take the part programs as input. Before that, you have a tape reader in the case of NC system, or punched card in the case of NC system. But here, this is a CNC system by using where you have a computer. In the last slide, we have seen that the programs are written in the computer. From the computer, so the programs will be fed into the machine control unit, where that program will be processed or analyzed and processed. According to that, it is going to generate one signal in the machine readable form. So that signal will be sent to the machine control unit, machine unit or machine tool unit. So where actual work will be performed. So this is the reference signal. The signal which is coming from the machine control unit is a reference signal, means theoretical signal. So as and when the signal comes to the machine tool unit, so according to this signal, according to the reference signal coming from the machine control unit, the table as well as the tool must need to move according to the reference signal. If there is any error in the movements or speed of the tool, or the movements of the table, so that error will be taken back. That will be sensed by the feedback device. That sensed signal, so that signal will be sent back to the control unit, and the difference of the reference signal and as well as the actual signal, the error between the reference and the actual signal, actual movements, actual and as well as the reference movements will be calculated. And again, we have a feedback signal, and that error will be analyzed and corrected. Again, the signal will be sent to the machine tool unit. So that is called the corrected signal or the control signal. So that control signal is again sent to the machine tool to correct the error. So in that way, this feedback device is going to sense the error, and this feedback device is going to intimate to the machine control unit to rectify the error. According to that error, one more signal will be generated, or the correcting signal that will be again sent to the machine tool. So this is what happens, and where the actual work will be performed. And in which case, actually what happens is, so this machine tool data is the signal will be sent to the driving system, and from there all the drives are going to operate on the machine tool to perform actual work. But here you have one signal. This is miscellaneous function, like you have M codes, so where actually which are related to the machine control operations. So here you have two types of data. One is motion data, which is specific to the motion data, and it is related to the machine control functions. Machine control functions like the coolant on, coolant off, program on, program off, when to start, then how to rotate the spindle, whether it needs to rotate in clockwise direction or anti-clockwise direction. So all these will take place. All these signals or the functions will be called as miscellaneous functions. But the functions related to the work is called the motion data. So that will be sent to the driving system, where those signals are converted as the machine readable form, and according to that the work will be performed on the machine tool. So this is what happens. This is what the cycle of the CNC system. The difference is that in the case of NC system, you have a hardwired system where we are going to use the punched card or a tape. The program is written on the punched card or a tape. In turn, you have a tape reader which reads the data, and that readed data will be sent to the or connected to the machine control unit. But here you have a computer where you can write the programs, and you can rectify if you find any error in the program. This is what happens in the case of the CNC system. Let me move on to the to discuss the basic components. As I said just now, this consists the input device. We have seen this consists the input device. Here you can find, and this consists the machine control unit, as we are discussed just now. the function of this machine control unit is to process the data, and that processed data is going to send to the driving system, and some data is sent to the driving system, and some data is sent to the machine tool. Then you have the driving system feedback devices, and you have a display device to see what is happening on the mission. You can also visualize on the display unit exactly what is happening. The function of the display unit is also to visualize the work before moving to the actual work. You can simulate the work before producing the actual work, or before going to the actual work. You can generate the tool path, how the tool is moving, whether we are producing correct work or not. You can visualize in this display unit. So these are all the basic components of CNC system. Let me move on to the functions of each component. As I said just now, the input devices are going to feed the program. The input devices like floppy drive, hard disk, CD-ROM, DVD, USB flash drive. So anything you can use, HDD, you can use to feed the program into the computer. Somewhere you can write and get that program into the computer, which is connected to the CNC machine tool. So these are the input devices commonly connected to the, commonly used to feed the program into the computer. Then you have other component, machine control unit. As I said just now, this will be treated as the heart of the CNC system. So where everything happens, most of the controlling system, most of the analyzing system, most of the signals are transformed from machine readable form will takes place at this location. So as I said just now, reads the coded instructions and fed them into it, and it also decodes the coded instruction, right? It is also going to implement the interpolation. I mean, the machine control unit is also having provision to implement whether to move tool linearly or circularly or helically. So that is also going to be decided in the machine tool unit, machine control unit only. So then it feeds the axis motion commands. Yes, it is going to execute the commands to amplify commands to the amplifier circuits for driving axis, for driving the axis mechanisms. Of course, it is going to amplify the circuits for driving the axis mechanisms. Yes, it is going to receive the feedback signal. If there is any error, it receives the feedback signal of positioning and as well as speed for each drive axis. And it also implements the auxiliary control functions such as cool and tal. Auxiliary control functions means machine control functions which are specific to the machine control functions. Cool and on, cool and off, program on, program off, spindle stop, spindle on, then spindle clockwise rotation, spindle anti-clockwise rotation. All this will be performed in using the machine control unit. So in turn, we can call these commands. So these commands are the M codes. M codes are the commands. Then the actual work or the positioning data will be called as the G codes. So we will see the coding in next chapter, G codes and NC programming part. We will see in depth how to program, how do you use the G codes and M codes, what is processing data and what is machine control data. We will see in the next chapters while reading the programming, part programming related to the NC or CNC machine. Then you have other component of the CNC system is a machine tool. So machine tool is always as a machine where actually actual work takes place. So it consists of sliding table, spindle control, and the positioning system. So the machine table is coordinated along X and Y axis, and the spindle is controlled in Z axis direction. Then you have a driving system. As I said just now, driving system is going to receive the signal from the machine control unit and the amplified signal, and it consists the amplified amplifier circuit. So this amplified signal will be read by the drive motors, and according to the circuit signal, this drive motor is going to act, and ball lead screw is going to move the table in different movements. The MCU, machine control units, feeds the signals of each axis to the amplifier circuits, as I said just now. So this amplifier circuit, this driving system consists of the amplifier circuit which receives the signal from MCU. Then controls the signals, the control signals from the amplifier circuits are then augmented, means uh, increased to actuate the driving motors. This amplifier signal is going to actuate the driving motors to run or to be converted into the signals to the mechanical work. That means the actuated signal will be sent to the actuated drive motors, in turn going to rotate the motors, and those motors are going to convert the electrical work into the mechanical work, to position the machine table as well as to rotate the spindle according to the actuated signal received from the machine control unit. Then you have the feedback devices. We have seen what is the function of the feedback device in the block diagram. As I said just now, it is going to read the signal, from the machine tool unit. If it finds any error, it is going to be corrected. Then the control signal will be sent back to the machine unit. That means machine control unit sends the reference signal to the machine unit, where if the signal, where the movements of the tool as well as the spindle finds any error, then the feedback signal will be generated. That feedback signal is again sent back to the machine control unit. So it generates one more signal for correcting the position and speed. So this machine control unit is going to send one more signal to the machine tool to correct the movements of the or the position of the table as well as the spindle. Then you have a display unit. As I said just now, the monitor is used to display the programs, commands, and other useful data. So with this display unit also you can visualize the tool path. You can also visualize the how the cutting will be performed without any disturbance. You can visualize everything at this location. You can animate before going into the actual production. You can visualize how cutting will be performed on the workplace. Then let us try to see the features of CNC. The function of the CNC is to store more number of programs. More than one part program can be stored, because more number of programs can be stored in a computer, because each computer is having a storage disk in which you can store more number of programs. That is the main feature of the CNC system. Then various forms of program input is also possible. Then program editing at the machine tool is also possible. I mean, machine tool, if you find any error in the program, at that location itself you can correct the program. Then you can re-execute that program to after rectifying the error in the program. That is also best feature of the CNC system. Whereas in the case of NC system, it is going to take the program using a punched card or a tape reader. So once you punch a tape, or once you prepare a tape, or once you prepare a punched card, I mean, you cannot rectify. Once you feed it, you need to execute those. It is not possible to rectify at the site itself. So you have to, that is also the disadvantage of the NC system. But here you have a very good feature that on the machine itself, you can rectify the program error, then you can re-execute that. So there you have an option to edit the program on the machine tool itself, on the machine itself. If the programmer finds any error during the execution of the program or during the work, you can rectify the program error, then you can re-execute. Then you have here you have fixed cycles and programming subroutines. Fixed cycles, is also possible here. Suppose you have to produce a drill of 20 mm in different locations in polar coordinates or rectangular coordinates. In that case, you can use a single program to reuse that. So if you use a program number of times, that is called a cycle. Suppose if you want to produce a hole of 20 mm diameter in the polar coordinates or rectangular coordinates, you can use a single program to generate or to produce a hole of same diameter. So that is also possible. Cycles or fixed cycles are possible. So those are, in turn, we can call it as a canned cycles. We will see what are canned cycles in the coming slides during the part programming chapter. Then you have the programming subroutines. Subroutines means even you can write a subprogram or subroutines that can be called any number of times. So this is also one feature. Program inside a feature. So program inside a program, you can call it as a subroutine. So then you can also interpolate the tool. You can decide how to move the tool, either in the straight line path or either in the curved path. That is also possible. Interpolation is easy in CNC machining because you have a computer. The calculations becoming very easily. You can interpolate the data. Then you have the positioning features for the setup. Setup positioning is very easy. Then you have cutter length and tool size compensation. Cutter length and size compensation is also easy here because you have a computer and you have written a program. Then in that program, the coordinate values are according to a certain length of tool. So suppose if you use a different tool of different length, the coordinate values will be adjusted according to the length of the tool. So that is called the tool length and size compensation. Once you write a program according to the specific program, if you use a different tool or if you use a tool of different size, the coordinate values in the program automatically changes. So that is also possible in the case of CNC machining. That means you can compensate, you can overcome the length and as well as the size of the tool in the case of CNC machines. Then communication interface, it is also having the communication interface. Then diagnostics is also possible. That means you can edit, you can reuse, you can rectify the programs as and when you require. This is all the features of the CNC machining centers. Now let us try to see the advantages of the CNC over NC. As I said just now, we are already listing out the advantages while discussing the block diagram of the CNC machining center and features of the CNC machining centers. So all those will be covered in this slide. Reduction in the hardware necessary because to add a machine function, reduction in hardware necessary because you have a computer, the hardware like punched tape, punched card, tape reader, you don't require in this case because you have a computer here. So that hardware necessary to manufacture the component, the hardware necessary to integrate the actual machine reduces. So new functions can be programmed into MCU as a software. New functions can be programmed because it is having a dedicated computer to store and to execute the programs. So new functions you can execute. That is also one advantage. Then CNC program can be written, stored, executed directly at the machining center itself. As I said just now, the machining center, if the programmer finds or if the machinist finds any error at the machining location, at that location itself, the error can be rectified and executed. It can be stored, it can be edited. Even if you want, you can write a program on the machine center itself. So you can write a new program on the machining center, you can store and you can execute directly at the machining center. This is the best feature of the CNC machining center when you compare with the NC, numerical control. Any portion of an entered program can be played back and edited to the edited, and tool motions can be electronically displayed upon the back. So any program can be played back and edited, and the tool motions can be electronically displayed upon the playback. So before going to the actual program, any program can be edit it and you can play that. Before going to the actual production, you can visualize the movements of the tool. This is what the one of the feature of the CNC machine. Then many different CNC programs can be stored in the MCU, number of programs, because you have a dedicated hard disk which is going to store number of programs. Then you have other advantages is can be updated, improving the software. So you are using one software. If you find any update in that software, easily you can update. This is also one advantage of the CNC machining center. So the flexibility is high. You can modify, you can edit, you can write a new program on the machining center so that you have more flexibility. As you can perform a variety of mixed operations and functions than NC. So you can combine number of operations at one location. You can perform variety of operations on a single machine. That is also possible in this. Then complete control using software rather than the hardwired NC. Hardwired NC means just now I said with you, punched card, tape. If you use those hardwired devices, hardwired attachments, really it is very difficult to control the machine. But if you have a software control, easily you can modify, easily you can edit, easily you can control the machine. Then I said with you just now, you can eliminate tape reader and tape reader, punched card in this case. This is also one advantage. Then this system, this type of CNC system is having the computer, so that you can, it is also having the display unit, so that you can shows the instructions being executed, and other operational data is also you can visualize from the display unit. Then manual data input is also possible even while another program is running. One program is running, then meanwhile the programmer need not be idle. He can write some other program, so that the resource persons, along with the working, the machinist is idle. During that time, the operator or the programmer or the machinist can do some attend other works also, so that he can write new programs, or he can also attend the other mission to feed the program, or to see or to visualize what is happening at the different locations. That is also possible. Then diagnostics is also possible here. If there is any error, if the programmer identifies any error, you can rectify. That is called the diagnostics. When it comes to the disadvantages of the CNC machines, costly setup, it requires the skilled operator, because programmers needs training. Then the operators require training to operate the sophisticated machines, because the machines are too costly. It requires the skilled operators, and the machine cost is high. These two are the major disadvantages of the CNC machining centers. It requires the computer programming knowledge, and it requires skilled operators and costly setup. Programming knowledge is required to program, and we cannot learn ourselves. We require some training to program on the machine. Maintenance is difficult, and all those should be placed in the air conditioning or low temperature, temperature controlled environment. This is also essential. This is also one disadvantage of the CNC machining centers. When it comes to the applications, applications of the CNC machines, it is used in the aerospace, automobile parts, where aerospace equipments are a complicated profile, like to produce the turbine, the machining coordinates varies continuously while moving the tool from one location to another location. The tool coordinates always varies, so that the aerospace equipment is having the advanced profiles like the B-spline surfaces. In that case, definitely we need to go for the CNC machines. Like to produce the turbine blades, impeller blades, we need to go for the CNC machines, because the profile of the turbine blades is also complicated. To produce the turbine profile, the tool movement is also continuously varies from one location to another location. And similarly, in the case of electronics industry also, even in the case of printed circuit board, the tool has to move from in a zigzag manner to produce the PCB. This is also one application. Then the other application is in electrical industry, to produce the coil winding, or to manufacture the coil winding. This CNC machines, these machines are useful. Then for then the these CNC machines are also used where the part geometry is so complex, like as I said just now, to machine the complicated shapes like the turbine blades, impeller blades. We require the where you want to machine the very complex shapes. In that case, CNC machines are ideal to manufacture, are ideal to machine. The operations are very complex, geometry is complex, and operations are also complex. In that case, we need to choose the CNC machines. For parts subjected to regularly design changes, I mean, this CNC machines are also used where the products are where the components are subjected to the design changes frequently. If any of the product design changes frequently, in that case, definitely we have to use this CNC machines. Then, then where you don't want the inspection 100%, if it is an NC machining, the defects may occur. Whenever you want to avoid, whenever you don't want to inspect the components which are produced from the machines, in that case, we can go for the CNC machines. In turn, we can say that the products which are coming out from the products which are manufactured from this on the CNC machine are 100% accurate. That means you don't require inspection department. So wherever you don't want inspection, in that case we can use CNC machines. Then let me move on to the one more NC we had discussed in the previous slides, previous classes. Then CNC we have discussed. Then you have other one, direct numerical control. In the case of direct numerical control, this is the working of the numerical control is a bit different when you compare with the NC and CNC. In the case of direct numerical control, in short, you can call it as a DNC. You have a central computer or a host computer or a mainframe computer where all the programs are going to fit. From there, different machines are going to different machines, different NC machines, different machine tools are connected to a single mainframe computer or a single host computer. I mean, the host computer is going to share the data, share the programs to the different computers which are connected parallelly to that computer. We can call it as a mainframe computer or a host computer. So where all the machines are going to get the program. The concept of the DNC you can see here. So you have a host computer, then you have where all the CNC programs are stored. So it is having a bulk memory computer. In turn, you can also call it as a bulk memory computer. That means the hard disk capacity of this host computer is high. That means more number of programs can be shared at this location. From there, number of machine control units are connected from the computer networks or from the cables. So these machine control units, number of machine control units or number of NC machines are connected to the host computer parallelly. So all these can be connected, all these machine tools, in turn machine control units are going to take the programs from the host computer. The advantage of the DNC computer is that a single program stored at one location can be used number of machines parallelly or at a time. That is the advantage of the DNC machine. When you go to the CNC machine, every CNC machine is having one dedicated computer where all the programs are stored, and according to that, machine control unit takes the program and it converts as a signals. Then according to those instructions, so machine tool is going to work. But whereas here you have only one host computer or bulk memory computer, this is going to be, this memory is shared by the different machine control units. In turn, these machine control units, MCUs, are connected to the NC machines. That means a single computer, host computer, or a bulk memory computer is shared by the different machines to perform or to get the actual work. This is what the advantage of the direct numerical control. So this host computer or the bulk memory computer is connected to the machine control unit. In turn, this machine control units, MCUs, are connected to the machine tools from the computer networks. So this is what the block diagram of the DNC system. I said the advantage is that a single computer is having a bulk memory where all the programs are stored, and those programs are shared by the different machines to perform the work. This is about the working of the direct numerical control. I said just now, part program is downloaded to the machines directly and omitting the tape reader. Tape reader is present in NC, even that tape reader and punched card is omitted in the CNC also. So we're not at all going to use punched card and tape reader in DNC also. It is outdated, and we're not going to use in DNC. Even CNC, we're not going to use tape reader and punched card. So this is not going to use, so that we are eliminating the tape reader or the punched card in DNC and as well as the CNC. Then when it comes to the basic systems requirements are, it must require a mainframe or a central computer where you can store more number of programs. Then it must have a bulk memory. These are all the basic requirements of the DNC system. It must have mainframe or a central computer which is having a more memory, and it must have telecommunication network. It should be able to connect the central computer or a main computer to the different machine control units, so that we require the telecommunication network. Then you have a machine tool to perform actual work. Then the next session, okay, let me go back what we have discussed as of now. You have we have discussed the direct numerical control. Then we have seen the block diagram of the direct numerical control systems where you have a central computer and which is shared by which is the program stored in the central computer will be shared by the different machines. Then we have discussed the advantages, applications of CNC machines. Then we are also discussed the disadvantages, then advantages of CNC over NC, then features of CNC were discussed. Then functions of each component of a CNC system we are discussed, which consists the display unit, feedback devices, driving system, machine tool, machine control unit. Then you have the input devices. We have discussed the functions of each component of CNC system in these slides. Then we have also gone through the block diagram of CNC machining system, how it is going to work. We have discussed how all these basic components are integrated together to get the actual work. We have also seen that. Then we are also discussed the classification of CNC machining centers, how the CNC machining centers are classified like NC machining centers. So almost all, most of the points are covered, similar to the classification of the NC and CNC are somewhat similar. I mean, almost all these are going to, the classification is similar to that of the NC machining center, except that the programming method, in this case absolute or incremental, and then you have the positioning control according to that, almost similar, open loop or it may be a closed loop according to the feedback, according to tool motion control. Then according to the program methods, which may be absolute or incremental, according to the type of controller, which may be hybrid controller or straight controller. Then according to the axis, how the axis is located, whether it is in the horizontal plane or in the vertical plane. or according to the type of operations, whether it is performing the specific, whether the CNC machine is performing only specific work which is designed to do, or perform only specific work. In that case also you can classify CNC machines as CNC turning center or CNC milling center. Then we have also seen the manufacturing methodology of modern CNC center. We are discussed the basic difference between NC machine and CNC machine. We are discussed with this manufacturing methodology of modern CNC center diagram. Then okay, this is what we are discussed in this slideshow. Then in the next session, we will try to discuss in detail about the DNC system. So let me introduce the DNC system in the next session also, before moving forward to the discussion of the basic components of the DNC system. We will discuss the glimpse of the block diagram of DNC system, because we are discussed in this slideshow itself what is DNC, how it is going to work, and the block diagram of the DNC were already discussed in this session. But I will introduce the same diagram in the next session. We will discuss the same diagram, block diagram, in the next session. But in the next session, we will discuss in detail about the each component of the DNC system, one by one. Every component we will look into: communication network, bulk memory, computer, then machining center. All we will discuss in the next class related to the DNC system. Then we will also discuss the working principle of the DNC system. So almost we are already discussed in this slide. So we will see the glimpse of working of the DNC system in the next session. Then we will see the functions of DNC. What exactly, if you implement DNC, what functions we expect. So those we will discuss. Then we move forward to discuss the advantages of DNC, advantages of CNC over NC we will see. Then a comparison between NC, CNC and DNC machine tools also we will see in the next session. So with this I close the session. Thank you one and all for this session.